Hello everyone. Welcome to the second lecture of pointer in C. In the first lecture we have defined what is a pointer and we have seen how we can use the pointer using the value at the address operator. We also see what are the permissible pointer arithmetic operation, and we have learned about the void pointer and the null pointer. In this discussion we are going to discuss the call by address concept in function calling. Then we are going to define a 1D array using the help of the pointer. We are going to access all the elements of a 1D array using the pointer of that array. We are going to discuss the concept of array of pointers and pointer to an array. So let's start. First of all, what is call by address? A call by address is a concept where we pass the address of a variable in the actual argument. So in case of call by value, which we have discussed in the function calling part, we are passing value of the variable as the actual argument. In this case, we are passing the address. So here, in case of call by value, the changes made in formal arguments are available to the called function only. That will not be reflected in the calling function, though their variable name will be same. So we have seen that in case of the function calling, we have seen that in the example of the function calling. If you remember, we have already explained why the value of a and b in the main function is not changed to 20 and 40 according to our code. Now, in case of call by address, as we have already mentioned that we pass the address of the variable as the actual argument. The formal arguments are the pointer of same data type of the variable whose addresses have been passed as the actual argument. So basically in the function declaration, the input argument will be a pointer of the same data type for which the value same data type as the variable for which we want to pass the value to the called function. Now, so that will be reflected in the function header also. As we are passing the pointer of the variables, it is possible to make changes in the calling function variables by using their pointers, or as we can change in the actual address, it is possible that the changes reflected in the changes will be reflected in the original variable in the calling function. So let us discuss that with an example. We are going to keep the example same as the function call by value concept. Here you can see that we are adding 10 and 20 to a and b respectively, but here we are using the concept of call by address. So as we are going to pass the address of two integer value, so that addresses need to be stored in a pointer. So in the declaration part, we are mentioning that the input arguments are basically two integer type of pointer. The function name is f underscore sp and its return type is void, so it is not returning any value. Then in the main function, what we are doing, we are asking for the value of a and b from the user and storing that into the a and b variable. Then we are showing the value present in a and b, whatever the value user given, that will be shown. Now here we are calling f underscore sp function with the by passing the address of a and address of b. So address of a will be stored in this a pointer and address of b will be stored in this b pointer in the called function. So from here the execution will come to the called function. So here a pointer will store the address of a and b pointer will store the address of b. Now what is happening? We are printing the value of asterisk a and asterisk b. That means it will print the value pointed by A pointer and pointed by B pointer respectively. Then we are going to add 10 to the value pointed by A pointer and 20 to that value pointed by B pointer. Then once again we are printing the value pointed by A pointer and pointed by B pointer respectively. Then from here the execution will come back to this printf statement, and here we are printing the A and B value in the main function or in the calling function. Then as and our function is going back to the operating system by executing the return 0 statement. So let me run the code first, then see what output we are getting. Then we are going to explain why we are getting that output. So if I give 10 as A value and 20 as B value, in this case, in this code, we are going to see that the main function, in main function A and B, initial value will be 10 and 20, and the final value will be 20 and 40. And in the f underscore sp function, the initial value of A and B will be 10 and 20, and the final value will be 20 and 40. So we are getting this output, what we are expecting. You can see that this is the code where we are using the concept of call by value. Now if we run this code, then you can see that for the same input, the main function variables does not change its value, but in case of call by address, the main function variable changes its value. Now let us explain why we are getting such kind of output. So as we have main function and fp underscore sp function, both of the function will maintain his own memory block, as we have discussed already in the function part. Now in case of main, there will be two variables A and B, which are of integer type. Now A variable, suppose its address will be 1000, and B variable is address will be 1004. We are considering these two values. Now the user is giving 10 value to A and 20 value to B. So this is the memory configuration for the main function. Now in case of f underscore sp function, its memory configuration will have two variable of two pointer variable. One is A and another is B. So remember, so please keep in mind that A and B are the two pointer variables available to this function only. This is not same as A and B. Now suppose its address is 2000 and its address is 2004. So what we are doing, when we are calling f underscore sp function with the address of A and address of B, actually we are passing the address of A into A pointer and address of B into B pointer. So what is the address of A? Address of A is 1000, so that will be stored in this A pointer for f underscore sp function, and the address of B, that is 1004, which will be stored in the B pointer in fp underscore sp function. So this A is now pointing to this memory location, and this B is now pointing to this memory location. Now, right, so in the f underscore sp function, when we are printing the initial value of star A, so star A is pointing to this value stored in 1000 address. So star A is basically star 1000. So this value is 10. Similarly, star B will give me 20. Then what we are doing, we are performing star A plus equals to 10. So this will be considered as, this will be evaluated as star A equals to star A plus 10. Now this star A means So this star a means star 1000 plus 10, and where it will be stored? It will be stored in this location. So this star a means 10 plus, so this value is actually the value of the original variable a, that is 10, plus 10, that is 20. And where this 20 will be stored? It will be stored in this location. So for this operation, we are actually making change in the original value of a, which is in the main function, by using its pointer. So a will become 20. Similarly, for star b plus equals to 20, that will be star b plus 20, which will be 20 plus 20, 40, and this 40 value will be stored in where? It will be stored in the address pointed by b, pointed by this b, which is 1004. So this 20 value in the main function will be removed and it will be replaced by this value. So this b become 40. Now if we print the value of star a in fp function, f underscore sp function, so this will give me 20, because star a means star 1000, and what is the current value of 1000 in the 1000 address? That is 20, and star b will give me 40. Now let us take in case of main function, when we are printing the initial value of a and b. So a was 10 and b was 20. Then when we are coming back to the main function from f underscore sp function, and we are printing the value of a and b, so what value we are having in a? We are having 20 value in a, and in b we are having 40 value. So you can see that by using the concept of pointer, we are able to make changes in the variable in the calling function. So by passing the address or using the call by address concept, we can access the variables in the calling function. So this is a very powerful feature. So now we are going to discuss the concept of function returning a pointer and a pointer to a function. As pointer is basically a variable, so function can return a variable. So function can return a pointer also. So how to declare a function which is going to return a pointer? So we need to mention the data type of the pointer the function going to return, followed by the function name, followed by the input argument of that function. So here in this declaration, we are actually saying that function func will take an input argument of integer type and going to return a integer type of pointer. So func is going to take an input argument of integer type and going to return an integer type of pointer. Now how we can define it? So let us take, this is my definition. So it is matching with the function, the function header is matching with the return with the function declaration. So there is no problem. Then a is an integer type of variable. We are performing a equals to a plus a into 10. Then instead of returning the value of a, we are returning the address of a. We are returning the address of an integer type of variable. So it is basically an integer type of pointer. So here we are matching the returned argument with the return type of the function. Now in the next part, we are in this parallel to this, there is a concept called pointer to a function. As the pointer definition says that it is a variable which can hold the address of a variable, or a function of same type. So a pointer can hold the address of a function also, but the function type should match with the pointer type. Clear? Let us first see the declaration of the pointer. So here we are saying that APTR is a pointer which will point to a function which take an integer value as an input argument and going to return a integer value. So see the fancy1 function declaration. The fancy1 function declaration, it is going to take an input argument of integer and going to return a integer. Function declaration of fancy1 is matching with the declaration of the APTR pointer. So APTR can hold the address of this function. And how can we assign the address of a function to a pointer? Obviously using the address of operator followed by the function name, and it will be assigned to the function pointer. Remember, this is only possible because the return type, or because the declaration or the function type is matching with the pointer type. It is not. If it is not, then the assignment will not be possible. It will give you a compilation error. Now, how can we call a function using the pointer? By using this notation: asterisk followed by the pointer name within bracket, then within bracket this 10 is actually the input argument to the called function. So if we use this notation for calling the function, which function it is going to call? It is going to call fancy1 function. And what input argument, or what will be the actual parameter to that function? 10. This 10 will be the actual parameter to the function. Now, here is a simple way to identify the difference between the function pointer and the function returning pointer. Here you can see that I have used a parenthesis when I am mentioning that it is a function to a pointer to a function. So by seeing the parenthesis, you can identify is it a pointer to a function or a function returning a pointer. Here you can see that there is no parenthesis. The reason is that pointer having lower precedence than the function. So to increase a precedence of a operator, we should use the first bracket or the parenthesis. That is why, as we are using that parenthesis, we are increasing the precedence of this operator, asterisk operator. So in the first case, it is function to function returning a pointer, because function have the higher precedence than the pointer. And here we are saying it as a pointer to a function, because the pointer, by using the parenthesis, we are giving more priority to the pointer part. We are going to discuss how we are going to realize a 1D array using the pointer. First thing you need to know that the array name is a constant pointer of the same data type as of array. So when we are declaring an array, suppose we are declaring int a 3 equals to 10, 20, 30, that array name a is a constant pointer. And what kind of pointer it will be? As the array type is of int, so array name a will be a integer type of constant pointer. As it is a constant pointer, operations like a plus plus or plus plus a, which will try to change the value of a, are not permissible, and they are going to give you a compilation error. The reason is that here the a is a constant, so we cannot change a value of a constant. That is why this kind of operation where we want to change that value of A that is restricted. Any array is a contiguous allocation of memory block of same type. What does this mean? Means here A is an integer type of array. So each and every block, and there are 3 blocks, so each and every block the size will be same as of an integer variable, and they will be allocated in the memory in continuous way. We are going to see that in a diagram in the next slide. So as I have told you that each block will be of same size of the data type as the array. So as it is an integer array, so each block will be of integer size of an integer variable. In 1D array name holds the base address. Base address means the address of the 0th cell. So here the array name A is actually holding the address of A0 cell. Now this is for 1D array. The 2D array, the array name will hold the base address, but the concept of base address is different in case of 2D array. We are going to see that in the next part of the lecture. So remember, A is actually holding the base address is equivalent to address of the A0 cell, and this is called the base address or the starting address. So let us understand array using is memory allocation. So here A is an array of integer type of size 5, and we are initializing that array by value 10, 20, 30, 40 and 50. Then we are having a pointer P of integer type. So let us concentrate on this diagram first. So A is the name of that array, and we know that array name is a constant pointer holding the starting address of that array or the base address of that array. Now this 1000, 1004, 1008, 1012, 1016 are basically the starting address of each and every block, considering the integer size is 4. So each and every block will be of 4 byte size, and the starting the first byte address of that block will be 1000, then for the second cell it will be 1004, then it will be 1008, 1012, 1016 respectively. So then if I ask what will be the value of A, remember A is the base address and it is a constant value. So, and base address in case of 1D array is actually equivalent to the address of A0 cell. From the diagram we can consider that the address of A0 cell is 1000. Similarly, the address of A1 cell is 1004, address of A2 cell is 8, 12 and 16 like this. So if I perform A++, what will happen? As you all know that array name itself is a constant pointer, and as it is a constant we cannot increment the value. So as we cannot increment the value, so this will give me a compilation error. Similarly, ++a or assigning any value to A is not permissible in case of when A is the array name. If I say, can I perform this operation? The answer will be yes, I can perform, because I am adding 1 to a pointer value. Remember, adding integer value or subtracting an integer value from a pointer is permissible operation. Now here we are not changing the value of A, we are just adding a value to A. So it is permissible, and if you remember, it will be A plus 1 into 4. Why 4? Because by formula we know that a plus I into size of the data type. Here the size of the data type is 4. So 1 into 4. So a will give me 1000 plus 4. So you can see that this is the address of the A1 cell. Similarly, if I perform a plus 3, then what value should I get? A plus 3 into 4, that is 1000 plus 12, 1012, which is the address of A3 cell. And if I perform A plus 7, then A into A plus 7 into 4, that is 1028. Remember, this is a valid address in the memory for this memory configuration. But 1000 and that address is not present in our array, but by using the address of using the array name, we can access this memory location, which is a valid memory location. That is why it is said that array, in case of C language, the array does not perform any bound checking. So using the array name, we can directly access any memory location which is in contiguous allocation with the array. Now, so a plus 0, what will be that value? 1000 plus 0. So it will be 1000. Now, if we use the value at the address concept, so if I write a star, then it will be written as star. If we write star a, then it can be written as star a plus 0, and we have seen that it is star 1000. So it will give me the value at the address 1000. What is that value? That is 10. Now, can we write this is the value of A0? Obviously, we can write. Similarly, if I perform A plus 3 whole star, what address we are getting? We are getting 1012, and by asterisk we are getting value at that address. What is that value? The value is 40. So which is the value of A3 cell. So from here we can say that AI is equivalent to asterisk A plus I. Right? Now, as we know that addition is commutative, then writing A plus I is similar to writing I plus A. So we can write this one also. So by this, we can say that it is equivalent to writing I A. So you may find that notation to access the ith element of a 1D array also. So why we can use this notation, that is hopefully that is clear to you. Then let us discuss that array with the help of a pointer. So A is an integer type of array and P is an integer type of pointer. So A is holding an address which is of an integer value. So we can assign the A value, we can assign the address stored in A in P, and this will give me no problem because their data type is same. As their data type is same, we can, to access the AI element, as they are having same value, to access the AI element we can use the P. How can I use? We know that AI equals to A star A plus I, then star, instead of A we can put P. So star P plus I, so P plus I whole star will give me the value present in AI. Now we can write this notation also. Actually, the C compiler, when you are using the AI notation, it will be the C compiler will evaluate it as A plus I whole star. So that is why writing P plus I whole star is similar to writing P square bracket I. So that is why this notation is also possible when P is having the same address as the base address of an array. Now, so why we go? So what is the advantage of using a pointer which can hold the address of an array? The thing is that you can clearly see that A plus plus is not possible, or plus plus A is not possible, as A is a constant pointer, but the same thing does not happen to P plus plus or plus plus P. The reason is that P is not a constant, right? So this is the advantage of using a pointer which can hold the address of an array. So let us see an example and see how this is working. So in this example, you can see that A is a array of integer type with 5 elements having 10, 20, 30 and 40. 10, 20, 30, 40 and 50, 5 values. Now P is a integer type of pointer. We are assigning the address of A in P. We are assigning the base address of A in P, and here in this loop we are printing all the elements of that array A, not using the A square bracket I, but using the pointer concept. So by using the P pointer which points to that array. So let us compile this code and see what output we are getting. So you can see that we are getting all the elements to an array. Now let us change the notation, and we are going to use the square bracket, but instead of the array name, we are going to use the square bracket with P. So let us first compile this code, and you can see that we are getting the same output. Now this concept of array, so when we are going to pass an entire array to a function, the concept of pointer which can hold the address of an array will be used rigorously. So we are going to see that kind of example in the. So finally we can say that A plus I is equals to the address of AI cell. Now let us discuss an array of pointers. It will be an array which can hold the address of other variable of same type. So let us come to the declaration part first. Here ARR is an array which can hold the address of 3 integer values. So ARR is an array of pointers. So what is ARR? Once again, ARR is an array which can hold 3 integer type of pointer or address of 3 integer type of variables. Now ARR here is an array, and the array size or the size of ARR will be, as there are 3 cells and each and every cell is holding an address. So as address is of size of unsigned integer, so it will be 3 into size of unsigned integer. For our consideration, it will be 3 into 4, that is 12 byte for the compiler we are using. As ARR is a array which can hold the address of 3 integer values. So here let us take A, B and C are 3 integer variables, and ARR is an array of 3 integer pointer. So we can write ARR0 equals to address of A, that is an integer variable. ARR1 is address of holding the address of B, and ARR2 is holding the address of C. So each and every cell of ARR array is actually holding an address of an integer type of variable. How can we access the value of A? By using ARR. If I want to access the value of A variable using ARR array, then we should write like this. So this will give me the address of A, because it is holding the address of A, and we note that by this notation we can access the value of A. Now the next thing we are going to discuss is pointer to an array. First, I notice that here the ARR, the asterisk ARR, we are writing in the parenthesis, and the parenthesis operator or the first bracket, why it is used? It is used to increase the precedence or the priority of an operator. Now in the precedence table, the square bracket or the array operator have higher precedence than the pointer operator. So in the first case, as we are not using the parenthesis, it is firstly an array for this square bracket, then a pointer for this asterisk. So it is array of pointers. Now in this case, we are using a parenthesis with the asterisk operator. So this asterisk operator will have the higher precedence. So we will say that ARR is a pointer to an array for this square bracket. So it is the pointer to an array. And how we can differentiate between array of pointer and pointer to an array? In array of pointer, the array operator of the square bracket will have the higher precedence. In case of the pointer to an array, the asterisk will have the higher precedence by using the parenthesis operator. That is also done in the function returning a pointer and pointer to an function. Let us discuss how we are going to explain the ARR. So ARR is a pointer which can hold the address of an integer array. Why integer array? Because we are mentioning it is an integer array. And how many elements will be there in that array? It will take it. The array will have 3 elements. So in total we will say ARR is a pointer which can hold the address of integer array of 3 elements. There will be 3 elements in the array of integers, and the pointer ARR can hold the address of that one. So let us come to the example first. Here A is an array of integer and its size is 3. So the elements are 10, 20, 30, and ARR is a pointer to an array of 3 elements. So we can write ARR equals to A. But suppose we declare ARR as this. So it says that it will point to an array which is of integer but with 5 elements. In that case, this is not a valid assignment because their data type is not matching, right? Similarly, if A its size is 5 or any value other than 3, that time also the assignment will not be possible. It will throw a compilation error because their data type is not matching. Remember, ARR is a pointer. So as it is a pointer, its size will be of size of unsigned integer. So what will be the size of ARR? Here the size of ARR will be 4 byte because in our compiler, the compiler we are using unsigned integer having a 4 byte of space. So in the previous case, the ARR was of 12 byte. In this case, it will be 4 byte, and for this notation, whatever the size of the array is, it will remain 4 byte. Now, here you need to see I add an integer value to ARR. What will be the next value of ARR? Now ARR is holding an address of an array. So if I increment the ARR by 1, it should hold the next possible address for another array. Now this array is taking, this A array is taking how much size? It is taking 3 into 4, that is 12 byte of size. 12 byte of, it is taking 3 into 4, 12 byte of space. As it is taking 12 byte of space, so here adding 1 to it means ARR will be incremented by 12. So if the initial value of ARR was 1000, then it will be the next then the ARR plus 1 will be 1012. So here for this example, if I perform ARR plus I, then the ARR value will be ARR plus I into 12 because the size of the array is 12. So in this way, actually we are going to use this concept of pointer to an array when we are going to implement a two-dimensional array using the pointer. So that's it for today's video. In the next video, we are going to discuss how to pass an entire array to a function. Then we are going to implement the two-dimensional array using the concept of pointers. Till then, stay safe and see you in the next video. Thank you.